So in the previous case, we had three cases. In the previous example, we had three cases of holding the data, loading it, the parallel load, or shifting. But sometimes we want to have more functions in it. If that's the case, we can use the multiplexers in order to determine what should be the input to each flip-flop at any rising edge of the clock. So indeed, we can place a 4-input multiplexer in front of each D flip-flop. If we want to have 4 operations in mind, we can have shifting towards the right, shifting towards the left, parallel load, and holding. And then we will have a shift register with 4 functionality with any of these operations that I just mentioned. And now we will see how this could be done. So keep in mind that here when we say that we have a shift right, it means that shifting towards the right by 1 bit position. And also it's the same for the shifting towards the left. Over there we also have shifting towards the left by 1 bit position. If you want, you can also have shifting by more than 1 bit position towards the right or towards the left. You can determine that, but then you need to change the structure of your shift register. You can instead use the multiple input multiplexer in order to specify what you want to do.